So I will be talking about the local sources of long-range transport of POPs and CEAC's future developments. So that's the focus today. Acknowledging our co-leads group that has been meeting for the last 2 years quite regularly. And these are assessment leaders who are working on various chapters of this assessment, which has actually 65 contributing authors. If you make one further click, you'll see that there is the page for environmental science advances showing the special issue. So what I'm going to be talking about along with Krystyna today is the first, the emerging evidence for new or increasing secondary sources of POPs and CEACs as the Arctic warms. And this deals with the releases from glacial melting and permafrost. And when we were doing this assessment, we were thinking very much about the locations where local communities might be impacted. And then the second part of our assessment of our article actually on this is related to the potential for increasing emissions of new sources of POPs and CEACs with future developments. And so I'll be focusing on that in the next few slides. And what I'm referring to are the things that are fairly well known to many who are watching this video. When you think about it, increasing transport, shipping, tourism, fishing, aquaculture, and agriculture, all associated with climate warming and opening of and retreat of Arctic sea ice and that sort of thing. And also the expansion of industrial and public infrastructure in the terrestrial environment with roads, airports, and harbors. And in the background also is the consideration of population growth and urbanization. Just a quick reminder that because we're dealing with a lot of chemical names, especially in Krystyna's talk, less so in mine, when we consider persistent organic pollutants or POPs, we're talking about the legacy chemicals that are listed on the Stockholm Convention and some newer ones that have been added in the last 20 years or so. So there's approximately 34. But a lot of our focus is actually on chemicals of emerging Arctic concern. And these are substances with similar properties to POPs, which are suspected of harmful effects and are being detected in the Arctic. And they are things like pesticides, current use pesticides, pharmaceuticals, industrial chemicals like flame retardants, and plastic and lubricant additives. And these chemicals are mainly used in consumer and industrial products, and they're generally not regulated or banned, or at least not in the same way that the legacy POPs are. And our assessment in 2016, we're now getting a little bit dated, but addressed 16 classes of chemicals like that. So that's what I'm referring to when you'll see CEACs used a lot in the subsequent slides. This slide, entitled Changing Pathways and Sources of Contaminants in a Warming Arctic, is we used a graphic that we borrowed from several other AMAP assessment reports and climate reports, and trying to encompass all of the, first, the climate-related and physical and ecological changes, changing air temperatures and greater precip, extreme weather, permafrost thaw, inland flooding, coastal erosion, and so on. Those are all circled in green. And if we keep clicking, you'll see the concern there, and this is something that Krystyna is going to deal with in her presentation, is the re-emissions from these old sources in many cases. And then if we continue, what we're looking at here is in my presentation, is really the commercial or economic aspects of all of this, the expansion of industrial and public infrastructure and shipping and so on. Let's go through then a series of slides where we look or dive into these topics in a bit more detail. So what essentially we've done is reviewed the literature looking for actual studies that have connected contaminant emissions to some of these issues. There's not very many, and so a lot of our discussion of this is somewhat speculative in terms of what emissions there might be of CEACs or POPs. But I think the purpose of this is to sort of raise awareness that there could be emissions. So looking at this expansion of shipping, the area regarded safe for shipping is expanded by 35% between 1979 and 2018. So, of course, I'm sure everyone listening has heard a lot about the potential for more transpolar traffic or traffic on the Northern Sea route, which is shown in the graphic to the right-hand side, and also to the Northwest Passage, which is through the Canadian archipelago, and also another shipping route, which is through Hudson Bay and around Greenland. There's even discussions in the literature about transpolar, in other words, shipping directly across the North Pole by 2050 during open water conditions because of the retreat of the projected retreat of sea ice. So the projected retreat or the sea ice minimums are shown in purple kinds of colors there on the slide. The 2007 minimum, which was extreme, and then the predicted minimums for 2030 through to 2080, or 2100. So you can see that the potential there for increased shipping. And of course, the CEACs associated with this would be chemicals that are in anti-fouling paints. Of course, there's oil and fuel spills, wastewater discharges, atmospheric emissions from the vessels, such as PEHs. And a few other little details on the slide also show, where there are currently harbors that are restricted by ice, but open harbors. So mainly you can see that the much increase in shipping could be where there already are open harbors. And you have the cruise shipping industry, for example, has expanded quite enormously into the Arctic already, with much greater numbers in Iceland and in Greenland and northern Norway. And this is on the expansion of military and civilian airports and related infrastructure. Already underway are lengthening and upgrading of airport runways. This has occurred recently in Greenland and Canada, and it's projected in Russia as well. And of course, military and commercial airports are already known sources of contamination, particularly with perfluorinated alkyl substances, or PFAS. And so we were sort of anticipating that expansion inevitably will lead to other sources of CEACs. And these could be associated with firefighting sites, with fuel spills, with lubricants, and with flame retardants. There are also the number of active military sites, not that it's necessarily increasing, but they're being perhaps more heavily used. On the map are shown with a red box the military sites which are capable of holding fighter or bomber aircraft. And these are circled all the way around the Arctic, and there's less known about the contaminant emissions from these sites. And of course, many of the sites are old, actually, and may have had other contamination issues in the past, which have been cleaned up, but maybe not sufficiently. And one of the topics that we looked at in our assessment was these formerly used defense sites, where the potential for releases due to permafrost degradation for waste that's been landfilled on these sites is quite a concern in some places, and Krystyna will touch on that in her presentation. Certainly in Alaska, these FUD sites are regarded in some sectors as being important sources of POPs. So moving to the next slide, which is on expansion of roads and railroads. I took this image from a paper from Forward et al. In Arctic Science, which is a very nice image of the railroad and road activity or network in the north. And of course, it's very elaborate in Nordic countries, but in Russia and Canada and Alaska, much less, and Greenland, much less so, of course. However, there are proposals for construction of railroads. You should see some red lines, which show the some of the current projects, an expansion of a rail line in northern Norway, also one to deliver oil products so that in Russia, so that they can be shipped through the Old River Delta, and northward expansions of roads and rail in Canada as well. So, and the railway in Canada associated with an iron ore mine. So it not as large changes on the terrestrial environment as we might expect in terms of the activity on the marine environment, but still quite significant. And of course, there are major significant existing corridors which could be impacted by permafrost degradation. And you can see that the Trans-Siberian Railroad is associated with discontinuous permafrost, as is part of the Yukon or the Alaska Highway that connects Yukon and Alaska in North America. Moving to the next slide, which is on expansion of fisheries. Already there's quite a significant increase in activity. The first image you'll see there shows the activity between 2013 and 2018 relative to 1982 to 2011. And you can see that the most fisheries activity is in the Barents Sea, quite a bit in the Bering Sea and the Sea of Okhotsk, and a little bit off the coast of East Greenland. But with a click, you'll see now you should see two images on the screen. The other one showing the activity in a future climate scenario for 2040, 2060. This is according to the article by Poshad et al. In Research Environmental Letters. And their projections are that there will be increased fisheries into Hudson Bay and along into Baffin Bay in between Greenland and Canada, and also more activity in the Barents Sea, and even fishing into the Chukchi Sea. So with this, we can expect increased emissions of CEACs, particularly antifouling chemicals on the ships, plastic litter, microplastics. And already I think it's understood that the fishing industry is the major source of plastic litter in the Arctic Ocean at the moment. So it's definitely a future concern as that fishery expands. So moving on to the next slide, which is the last one in terms of my various expansions, the expansion of agricultural areas, which is based on a paper mainly that we found by Hannah et al., which is very interesting. They project this for the world, but we've narrowed it down to the circumpolar area. And these authors made predictions based on what they called commodity frontiers, referring to the suitability for cold-tolerant temperate crops, and intensification frontiers, where there would actually be northward expansion of existing cropland. So there could be, of course, greater use of greenhouses. It's already widely used, but maybe expanded because of the improved winter temperature regime. But then also the expansion of cropland. In both cases, you can expect greater use of pesticides, which ultimately could end up in runoff into river catchments that drain directly into the Arctic Ocean and Bering Sea. So this has potential then to bring fairly well documented chemicals, registered pesticides, but into areas that previously they wouldn't have been detected in. This is a slide which is a little bit of a change of direction. It's on the consultation and engagement of Arctic Indigenous peoples. But we tried to address this in a brief way in our article, because it really, since we're dealing now with the approval of developments, it really does involve the engagement of northern communities and Arctic Indigenous peoples organizations. Historically, there has been very little consultation with northern communities. Looking back into the building of military bases and radar sites and so on in the 1950s, for example. But this situation has changed since the 1990s, particularly in Greenland and in Canada, with greater self-governance in both regions, in both countries. And already there's consultation with Indigenous communities and stakeholders is a legal requirement in Norway and Sweden. The Nordic Sami Convention requires national governments to negotiate with the Sami parliaments, and the U.S. Federal government agencies are required to consult Alaskan Native governments. In Russia, the legal obligations for Indigenous participation are less clear from the information that I could find. Apparently there's no great general requirement for the Russian government to consult on development decisions, but regional governments have enacted more stringent Indigenous consultation mechanisms. So a conclusion here that we came to, although it's not supported by a lot of independent research, I guess you could say, is that building of roads, airports, and harbor expansions seem to have broader support from northern communities and Indigenous organizations, and possibly because these open up opportunities for local communities to have travel, communication, recreational, and subsistence activity. But proposals for mines and other kinds of development are, obviously going to be met with a lot of opposition, or at least with demands for much consultation. And this therefore means that to a great extent, some of the predictions that we might have about emissions are really related to the amount of engagement of the Indigenous peoples. There's the potential for releases of CEACs associated with natural resource development. I haven't specifically mentioned it, but there is the expansion of oil and gas production in the Russian sector, which, for example, and there's the expansion of mining in all countries. There's the expansion of shipping, which I've discussed, and the air emissions associated with that, as well as the anti-fouling chemicals and wastewater releases. The expansion of fisheries and aquaculture. Aquaculture being a big topic and a big industry, especially in Norway and in Iceland, and in northern and Kola Peninsula in Russia. Potential expansion there. Airport, seaport, and road rail expansions and the associated contamination, and the northward expansion of agriculture with the potential for increased pesticide use in northern river watersheds. I'll just list our conclusions so up to now in terms of this future developments aspect. We see that climate change and expansion of economic development are likely to increase the importance of local CEAC emissions. And it would be very good if the development projections that are being made could include estimates of the use and emissions of CEACs. However, it's a challenge, admittedly, because there's a lack of data for many CEACs in terms of, what to the extent to which they're in products that might be used in the development, for example, and there are their emissions from those products. There's a need to measure and model other CEACs, particularly those related to the increased economic activity. And related more to the existing sites, there's a need for an expanded database of polluted sites across the Arctic due to the mining, oil and gas development, former and current military bases, and also community solid waste landfills. And finally, a need to fully assess the emissions of POPs and CEACs requires greater involvement of Indigenous peoples organizations and northern communities. And we feel this would help in any case to identify issues, to monitor events and trends, and to interpret and communicate findings related to this development. Just to give everyone a heads up that what I've been presenting here is available in this article, which was published earlier this year in Environmental Science Advances as part of the special issue, and that QR image on the screen will link you directly to the article, I think, and it's open access. Just listing the upcoming webinars, which are starting on in 2 weeks. I'd like to now turn it over to Krystyna for the next presentation.
Hello, thank you very much for carrying out this topic. We stay with the outlook to the future of what will happen with contaminant releases connected to climate change in the Arctic. My name is Krystyna Kozioł. I work at Kazimierz Wielki University in Bydgoszcz in Poland, and I have been involved in various projects connected to persistent organic pollutants, especially, and the processes that contribute to their transport in the environment, and also those processes that connect to climate change. And most recently, the Perth-Water project, which connects to permafrost as a potential source of PAHs. But here I will speak on joint work. So let's give credit where credit is due. First, to co-authors of this article, which Derek has introduced. It is a part of a special issue where you will find further studies connected to the topic. And I reiterate with this figure that due to climate change, there are various processes connected to the expansion of infrastructure, like Derek said, but there are also various processes which connect, especially to the warming and therefore to glacier melt, to permafrost thaw, to thinning of the sea ice, and increased risk and frequency and intensity of wildfires, all of which may lead to emissions or re-emissions, remobilizations of persistent organic pollutants in the environment. And all these remobilizations, so reintroducing the same contaminant that has been deposited before, are referred to as secondary sources. They may be a little confusing from the point of view of determining whether a pollutant is long-range transported or not, because it is kind of a local source, but it is from a former emission elsewhere and from former long-range transport. So it's important to recognize that these processes already occur in the Arctic. And to explain the concept, I will first introduce the timeline of example pollutants, both already considered POPs according to Stockholm Convention, and considered also contaminants of emerging Arctic concern, CACEs. And these examples include PCBs, polychlorinated biphenyls, which have been manufactured since 1930s, essentially. Then, since the Second World War, organochlorine pesticides such as DDT or lindane have been widely used as insecticides. Since 1950s, PFAS, most of which are still considered contaminants of emerging Arctic concern, but some of them have been already listed by the Stockholm Convention as POPs, have been manufactured widely since 1950s, so they have also been around for several decades. Polybrominated diphenyl ethers have been widely used since 1970s. They are part of a group of polybrominated flame retardants manufactured since 1960s. And so there have been several decades of emissions. And only in the 70s started the bans or restrictions on these pollutants, such as the US ban on DDT in 1972, or EPA ban on PCBs from 1978. But they have been introduced at different points across the world. So when it concerns when they could have been transported into the Arctic, this could still have happened from other countries. And only the Stockholm Convention since 2001 starts to regulate an increasing number of pollutants in a large number of countries. So we had all this time for these pollutants to be long-range transported into the Arctic. And for a long time, it has been considered a final stop in this journey because of what we call cold condensation. So in these cold climates in the Arctic or in high mountains, the atmospheric deposition has been locking these pollutants in snow, which on glaciers transforms them to firn and glacier ice. And it could have been a long-term storage, but for climate change, which leads to re-emission as secondary pollution sources. And we know that due to this longer transported deposition in several remote locations in the Arctic, both POPs and CaCEs have been detected in ice cores. In Alaska, the organochlora in pesticides, in Svalbard, in the remote Ostfauna ice cap, both the legacy and the current use pesticides, Lomonosofauna, PCBs, PFAS, halted fauna also in Svalbard, again, 2 types of pesticides or 2 groups of pesticides, and also in Nunavut in Canada, in Devon Ice Cap and Mount Oxford ice field, there have been found various CaCs such as PFAS, organophosphate, flame retardants, or plasticizers. So there's several studies that show this deposition of POPs and CaCs in Arctic glaciers. However, there's much fewer studies that show what happens afterwards with the climate change. I will show a few examples. One of them is by Nicoletta Adamolo and co-authors from Kongsfjorden, where they sampled seawater in front of Kongsvegen glaciers at increasing distances at 2 times of the year, which is in late winter and in early summer, in March and June. Late winter still being an accumulation period on the glacier when more snow falls than is melting. And in early summer, there is more snow melt and ice melt. And in this early summer, the concentrations were higher. And furthermore, they decreased with distance from the glacier in the fjord, which points to the glacier melt as a source of, in this case, polychlorinated biphenyls. There are also multiple studies from Lake Hazen, the largest lake in the Arctic. This example comes from the study by McInnes and others on PFAS, especially on the figure is shown perfluorooctanoic acid, which already is listed in the Stockholm Convention. And you can see on this orange line, which signifies the concentrations in Lake Hazen, that its increase in concentration coincided with the glacial discharge contribution, this gray background. Not so much in another lake listed here for comparison, the B35. So it can also be connected to melting, the glacial melt, this source of PFAS. A further study that shows the impact on ecosystem comes from Northeast Greenland by Francesca Spataro and others. And it focuses on fish tissues of polar cod into environments, fjord waters and shelf waters, where fjord waters were impacted more by glacial melt, shelf not so much. And in terms of DDT concentrations, they have dropped significantly between the fjord and the shelf, showing that there could be glacial meltwater impact on these fish tissues in terms of this legacy pollutant. I think this shows that glacial ice and glacial melt can be a secondary source of pollutants of various kinds in the Arctic. However, it's not only glaciers that accumulate atmospheric waters, especially the ice-rich permafrost called Tiedoma in some parts of the world. In ice wedges, when they form, they accumulate meltwater from snow in increasing ice layers when they grow. However, as they thaw due to climate change, then they form ponds. These ponds may drain, and this may be released to surface waters. So again, former atmospheric deposition can be accumulated in permafrost and then impact, for example, surface waters quality by introducing formerly deposited pollutants. And let's mention here that the northern communities, including the indigenous ones, are very closely connected to permafrost, which covers 25% of land surface in the northern hemisphere. So, for example, here you see a picture of food storage, a sort of cellar made in permafrost ice in northeastern Siberia, where they store, for example, fish from these waters. And these waters are also a means of travel in this area in the summer. So I think it shows that these communities are dependent also on the water quality, and it should be of interest what permafrost may release into those waters. Again, with this picture of Yadoma Cliff, so this ice-rich permafrost from northeastern Siberia, I will start showing examples of impacts or studies that looked into permafrost concentrations of various pollutants from these two groups that we focus on today. And the first study comes admittedly from a mining area, so that's G and others. In the Yamal mining area in Russia, they were studying the impacts of PAHs in increasing distances from the mines. And they have determined that the high molecular weight PAHs have indeed decreased with distance, and they have accumulated on near the top of the permafrost table. So this is more of an impact of industrial activity. However, they have also discovered that within permafrost, there were high concentrations of these lower molecular weight PAHs, such as naphthalene or phenanthrene, 2 and 3 ring PAHs. In other study, for example, by Vasilchuk and others, they have connected these PAHs more to wildfires or plant matter. So there may be various sources of especially PAHs in permafrost areas. And here I will digress a little to tell more about wildfires. And there have been increased intensity and increased frequency of wildfires across the Arctic. And especially they have moved further north. They are more frequent in the tundra and also upwards of tree line in the mountains, which you can see here superimposed on the map of summer average temperatures in the Arctic. And in the warmer tundra areas, the fires are more frequent. But also the subarctic and boreal fires, which are becoming more frequent, may lead to longer transport of smoke to the high Arctic, bringing with it pollutants such as especially PAHs, including the benzoalpha-pyrene, which we normally monitor in city smog. It's a carcinogen. And here, due to the wildfires, its concentration is predicted to increase 8-fold. That was a prediction for the last decade. So yeah, generally it's an increasing concern. This may also lead to additional emissions of already deposited POPs of other types, or generally pollutants of other types. And there have been even discussions of the novel synthesis during the fires of some chlorinated organic compounds. And also dioxin or furan emissions in the Arctic are predicted to have increased due to the increasing wildfire activity. And of course, the wildfires that I already mentioned in the very northern areas are a concern for local communities. While we have one example in the set of articles from Maria Gunnarsdottir and others of a wildfire in subarctic or within the AMAP Arctic area in Iceland, near Reykjavik, where the wildfire has impacted concentrations of PAHs and also the volatile organic compounds BTEX in groundwater, which has spurred monitoring actions because of this concern for water quality. So indeed, wildfires are a source of various pollutants, including PAHs, which could have accumulated also in the past in permafrost. In one of the Rex articles, you will find this estimation based on the relatively few data that we have on permafrost, that there could be as much as 9 megatons of PAHs or various polycyclic aromatic compounds in the upper 100 centimeters of soil and peat in permafrost areas, which is more than 15 times maximum global emissions of PAHs noted in 1995. So potentially with the permafrost thaw, this is a problem of global significance. However, it's not only PAHs. Other pollutants have also been shown to be remobilized from permafrost. A study by Eckmeyer and others from Mackenzie Delta shows that lakes affected by tow slumps, of which an example you have here, but from Alaska in the picture. So this liquefying of the top layer of sediment and soil because of the ice thaw in permafrost can impact the concentrations in lakes, which are very abundant in the permafrost areas. So in this slide, you see the slump-affected lakes and the concentrations of PCBs, chlorobenzenes, and DDTs. On the next slide, for comparison, the non-affected lakes. With the same axis, it can be seen that the concentrations in slump-affected lakes are indeed higher. And another similar example from before unpublished data, now published by this article in Environmental Science Advances that we talk about today, but coming from Anna Caporizo and others. It's PCBs in East and West Lake in Melville Island, Canada, where West Lake was more affected by subaqueous thaw slumps, which led to higher turbidity, marked here with the gray line. And also that resulted in high concentrations of PCB 153, marked here with red, in the mussel of landlocked Arctic char in this lake. So another example that these remobilizations, releases of pollutants can lead to ecosystem effects in the Arctic. But it's not all due to the long transported deposited pollutants. There is also the risk that infrastructure, either abandoned or still in use in the Arctic, will be damaged because of the permafrost thaw. Permafrost thaw may lead to instability of various structures such as storages, tanks, pipelines, waste storages, landfills, mining sites, etc. And also in certain places there is increased thermocast activity, which may also contribute to instability, and also there may be leaks into these new pockets of water. Some of these sites are still in use. Some of them have been established specifically in permafrost areas because it was considered a good seal, a good locked storage for various wastes. Unfortunately, that isn't so anymore due to climate change. And Langer and others have estimated how much risk is there due to this effect. First, they mapped the polluted sites where there were accessible data and modeled the distribution across the Arctic. And here is a map that they produced with the top densities being as high as 1 site per 100 kilometers square, which, given that it's the Arctic, it's quite high density. And they have also predicted with 2 climate scenarios and the representative climate pathway with 2 different radiative forcings, which now in the new IPCC assessment, it would be more the shared socioeconomic pathways, but the radiative forcing seems it's more or less the same in the low emission, 2.6, and in the high emission scenario, 8.5. So in their estimation, the contaminated sites on degrading permafrost may increase by the 2100 to as much as 7,000 or 8,000 sites with the benign climate scenario, and in the more business as usual high emission scenario, this may be as high as more than 12,000 sites, contaminated sites on degrading permafrost subject to this risk of leaks. Some of them are industrial sites on degrading permafrost, and these industrial sites can be as many as 4,000 by 2100. To conclude on this topic, climate change leads to various secondary sources of both legacy persistent organic pollutants and what we consider contaminants of emerging Arctic concern, both due to glaciers melting and permafrost thaw in the Arctic, but also increased emissions from wildfires, which may also remobilize pollutants. The position to Arctic glaciers is better known than the impacts of it, and it doesn't only concern the legacy pollutants, but also the CACs, which is a potentially important issue for communities and ecosystems. Furthermore, permafrost degradation may also be a source of both natural and anthropogenic PAHs, but also of the more likely anthropogenic PCBs, organochlorine pesticides, also contaminants of emerging Arctic concern, for example, organophosphate flame retardants have been mentioned in one of the studies of PFAS. The thaw of permafrost may also increase the migration of POPs and CACs. There's more hydrological connections within the thawing permafrost. Sometimes the groundwater pathways form very deep, and this may lead to unexpected places for the pollutant emissions. And also further contaminants may be released due to permafrost thaw, breaking the isolation of all this industrial waste and also former military sites, such as the dew line in the Arctic. We also came up with some recommendations within this work. We need to provide more information on potential harmful impacts of such contaminant releases, especially focusing on water and food resources for Arctic communities, which I mentioned that are important also for the indigenous peoples in the Arctic. It is important to incorporate this risk into management policies and strategies implemented in the Arctic. And it would be helpful for this purpose to expand the database of polluted sites so that we're not surprised by these leaks. And with this, I thank you for listening. I also thank all the projects that were involved in preparation of this work and my co-authors of this study. And I'm happy to take questions in the discussion.